Hello! In this video, we are going to prove the following theorem. Let a be a real number. If a is greater than 0, then for all natural numbers n, a to the power of n is greater than 0. Okay, now before we get to the proof, we are going to say that exponentiation with the natural numbers is defined as follows. Given any real number a, we define a to the power of 0 to be 1, and a to the power of p plus 1 to be a to the power of p times a, for all natural numbers p. Okay, so let's get into the proof. To start with the proof, let's give ourselves a real number a where a is greater than 0. From here, our goal is to show that for all natural numbers n, a to the power of n is greater than 0. And since we're trying to prove the same about all natural numbers, let's use induction. So let's start with the base case. In the base case, we're trying to prove that this is true in the case where n is equal to 0, which means we're trying to show that a to the power of 0 is greater than 0. Well, let me start out by writing a to the power of 0. Well, from our definition of exponentiation, we know that a to the power of 0 is equal to 1. And as we all know, 1 is greater than 0. So as you can see, a to the power of 0 is greater than 0. So we have shown that this is true in the case where n is equal to 0. So this completes the base case. Now let's move on to the induction step. In the induction step, we give ourselves an arbitrary natural number n where this is true. And the whole goal of the induction step now is to prove that this is also true for n plus 1. Meaning, we want to prove that a to the power of n plus 1 is greater than 0. And to see how that comes together, let me start out by writing a to the power of n plus 1. Now, from our definition of exponentiation, we know that a to the power of n plus 1 is equal to a to the power of n times a. However, since a to the power of n is greater than 0, and a is greater than 0, we are multiplying two positive numbers. We know that the product of two positive numbers is also positive. So as you can see, we have that a to the power of n plus 1 is greater than 0. And that was the goal of the induction step. So this completes the induction step. So since we've completed both the base case and the induction step, this closes the induction. Which means we have proven for all natural numbers n, this is true. So putting this all together, we gave ourselves an arbitrary real number a that is greater than 0. And we showed that this is true. So, for any real number a that is greater than 0, this is true. So, we have proven this statement. So, this completes the proof. And so, yeah, that's pretty much it for this video.